Okay, let's take a look at some non-linear systems. So we've got a couple of equations here. Now take a look at, I've just done a quick rough sketch of what it might look like. Here's the x squared graph, or it should be x squared plus 1, but here's an x squared graph, and here's a linear graph. Now can you see basically we're going to have two answers, okay? Something that crosses through, say, a circle. We'll have two answers, okay? So we should get two answers for this. Okay, so let's take a look. Now we're going to do this by substitution. Now, actually, it doesn't really matter what I do. They've both got y equals. I mean, supposing I put that, if that's y, I'm going to put it there into the second equation. In other words, I'll have this. X squared plus 1 equals 6x minus 4. Okay? Right, that looks like it's going to be a quadratic. So let's take away the 6x from both sides and add the 4. We're going to get this. X squared minus 6x. What's that? Add the 4 to both sides. We're going to get plus 5 equals 0. Okay? Right, so that's going to give us, what's that? X minus 5, x minus 1. So x equals 1 and x equals 5. Which, if you think about it, you go back and think about where that graph was. If I'll do it again, maybe something like that. Yeah, maybe it's going to go through x equals 1 and x equals 5, maybe, okay? So those are my two x values. Now, I have to plug it back in to find out what y equals. So I guess we can use whichever we want to. So if x equals 1, what's 1 squared plus 1? Y must be 2. If x equals 5, what's 5 squared plus 1? That's y equals 26. And it work on both. So again, my two solutions are 1, 2 and 5, 26. Okay? Right, let's take a look at another one. Again, now this is definitely substitution. Doesn't matter what you do here. I suppose I could do something like this. Right, x equals 15 minus y. Okay, there you go. That's what x equals. I took away y from both sides. I'm now going to put it into here and square it. So it's 15 minus y squared plus y squared equals 113. Right, that should be squared. Right, so 15 minus, remember, 15 minus y times 15 minus y. Don't just square the 15 and the y. So 15 times 15, that's 225. That's minus 15y minus 15y is minus 30y plus y squared. Plus y squared equals 113. Okay, remember that one already there. So I have this. 2y squared minus 30y. I'm going to take away 113 from both sides. Okay, so that's plus 112 equals 0. Okay, let's divide everything by 2. So y squared minus 15y plus, what's that, 56 equals 0. That should factor into, let's get this, y minus 8, y minus 7. Okay, so it looks like y equals 7 and y equals 8. Okay, so what does x equal? Well, let's just put it into here. Okay, or rather into here, right? 15 take away 7 is 8. 15 take away 8 is 7. So 8, 7 and 7, 8 must be the solutions. Okay, let's keep on going. Now then, this is one. Now most of the time you do a substitution with these non-linear systems, but this is one that you can actually do elimination with. So okay, normally it's substitution, but watch, when you add these two together, you can see they'll cancel. So I have 2x squared equals, what's that, 162? Divide both sides by 2. Square root, x equals plus and minus 9. Okay? So when I plug that back in, I guess I'll plug it back into the first one here. Right. X squared, that is 81. Plus y squared equals 130. Now actually it doesn't matter whether I put the 9 or the negative 9 into there, I'll still get 81. So take away 81 from both sides. Y squared equals, I believe that is 49. Good. So y equals plus and minus 7. Now be careful, what we're going to say here is these are solutions. If I put 9 in, I am going to get 7 out, but I'm also going to get negative 7 out. Okay? If I put the negative 9 in and do it again, I will also get 7 out. and negative 7 out. Okay? And the reason why that is that could be, I mean, just supposing you have something like this, all right? Then can you see you have 1, 2, 3, 4 answers, if it was something like that. So that is the solution to that particular, okay?